Welcome to The Explainer. Today we're tackling a massive question, maybe one of the oldest ones we've ever asked. What is our place in the universe? You know, for thousands of years, everyone on Earth looked up at the exact same sky. So how did we go from thinking it was just a giant clock to figuring out how to measure our entire planet with just a stick? It's all part of this epic quest to find the center of, well, everything. So let's dig in. How did our ancestors even begin to piece together this cosmic puzzle? All right, so long before we started thinking about complex models and fancy math, the sky was first and foremost a tool for survival. If you go back, say, 5,000 years, you'll find people in places like Egypt and China just staring at the sky. And they weren't just daydreaming. This was serious business. They were creating calendars, figuring out the perfect time to plant and harvest their crops, even using the stars to navigate across vast oceans. And of course, for a lot of them, the sky was where the gods lived. So reading the stars was like trying to read the minds of the gods. And this knowledge wasn't just stuff they passed down in stories. No, they literally set it in stone. Think about something like Stonehenge. It's basically a giant ancient calendar. Those massive stones are lined up perfectly to catch the sunrise on the summer solstice, the longest day of the year. I mean, that's how important tracking the sun was to them. It was truly monumental. But then, everything started to change. The real game changer came with the ancient Greeks. See, they took all that practical knowledge from older civilizations, but they started asking totally different kinds of questions. They weren't just asking when, they were asking what and why. So right away, you have this big debate. On one side, you've got guys like Thales of Miletus who thought, okay, the Earth is a big flat disk and it's just floating on water. Makes sense, right? But then you have Pythagoras, who was all about the beauty of math. For him, the most perfect shape was the sphere. So he figured, hey, the Earth must be a sphere. And not just the Earth. Everything up there in the sky has to be a perfect sphere, too. Okay, so this wasn't just a philosophical debate about pretty shapes. The great Aristotle came along and basically said, guys, we can solve this. He brought actual observable proof to the table. Two really simple things anybody could see for themselves. First, he said, just watch a ship sail away. Its hull vanishes over the horizon before the top of its mast does. That can only happen on a curve. And second, and this is the clincher, he looked at the shadow the Earth casts on the moon during a lunar eclipse. That shadow is always a perfect circle. Think about it. A flat disk would cast a line or an oval shadow, right? Only a sphere casts a perfectly round shadow every single time. Boom, case closed. So, the Earth is a sphere. Check. That kind of settles one big question, but it immediately opens up another, even bigger one. It's like the next cosmic domino is about to fall. If we're on this giant ball, what is this ball moving around? Now, the obvious common sense answer was the geocentric model. I mean, it feels like we're standing still, right? And it looks like the sun and all the stars are the ones doing the moving. But there were a few thinkers who started playing with a really radical idea, the heliocentric model, with the sun at the center. And this is where a guy named Aristarchus of Samos steps onto the stage. He was an absolute genius. Using some pretty clever geometry, he figured out that the sun was way bigger than the Earth. His numbers weren't spot on, but his logic was revolutionary. He just asked, doesn't it make more sense for the little thing to orbit the big thing? He basically proposed that our Earth wasn't special. It was just another planet spinning around and orbiting the sun. And guess what? He was totally right. But his idea? It was just too much for people to handle back then. Suggesting the Earth wasn't the center of it all? That was basically heresy, an act of impiety. It went against everything they believed, philosophically and religiously. So his brilliant idea was pretty much thrown out and forgotten for more than 1,000 years. Unbelievable! So, while that incredible sun-centered idea was basically buried, another Greek thinker was about to take those same geometric principles and do something just as mind-blowing, but way more practical. He was going to measure the entire planet. Let me introduce you to Eratosthenes. This guy was the head librarian at the famous Library of Alexandria, which was like the Google of the ancient world. But he had this kind of sad nickname. They called him Beta. Yeah, Beta, like the second letter of the alphabet, because people thought he was the second best at everything. But trust me, his second best was about to blow everyone's minds. Okay, so how did he do it? His method is just pure genius. He heard a report that in a city to the south, CN, on the day of the summer solstice, the sun was directly overhead. It shone straight down to the bottom of a deep well, no shadows. But in his own city, Alexandria, at that exact same moment, a vertical stick cast a shadow. He measured that shadow's angle and found it was about 7.2 degrees. And that's when the light bulb went on. The only reason for that shadow was the curve of the Earth. Those 7.2 degrees represented the slice of the Earth between the two cities.
So we had the angle. Now we just needed to know the distance between the two cities. So we actually hired a guy whose job it was to pace out long distances and paid him to walk from Alexandria to Siena. Once he had the angle and the distance, it was just simple math. He calculated the Earth's full circumference to be 252,000 stadia, which is, for us, around 39,740 kilometers.
And here's the part that just makes your jaw drop. That number, the one he came up with over 2,000 years ago with a stick, a well, and some walking, is less than 1% off from the value we have today using satellites and GPS. Less than 1%. So much for being beta. That was a totally alpha move. So let's recap. The Greeks proved the Earth was a sphere, and they even measured it with stunning accuracy. And yet, that simple, correct, sun-centered model from Aristarchus? It stayed buried. Instead, astronomy went down a much, much more complicated road. Here's the problem with an Earth-centered universe. The planets don't move smoothly across the sky. They seem to speed up, slow down, and sometimes even go backward for a bit. It's weird. So to make the math work while keeping Earth at the center, astronomers came up with this really clever but super complicated fix. They invented epicycles. Imagine a planet moving in a small circle, while that small circle moves along a bigger circle. Circles on circles. It was a way to force the observations to fit the model they wanted to be true. And this whole complicated system reached its absolute peak with a guy named Claudius Ptolemy. His book, the Almagesto, was a monster of a textbook. It was a mathematical masterpiece that used all these epicycles to create charts that could predict where the planets would be in the sky with incredible accuracy. See, his goal wasn't really to describe reality. It was to create a tool that worked for making predictions. And in that, he absolutely succeeded. And because it worked so well, Ptolemy's Almagesto became the book on astronomy for, get this, 1,300 years. It had some pretty major flaws, like its math predicted the moon should sometimes appear twice as big as it does at other times, which it obviously doesn't, but those flaws were just ignored. Why? Because the model was good enough, and more importantly, it lined up perfectly with the philosophical and religious idea that humans were special, right at the center of the whole universe. And for one last amazing plot twist. Remember Eratosthenes' super accurate measurement of the Earth? Well, over the centuries, that knowledge was mostly lost in Europe. So when a guy named Christopher Columbus was planning his trip, he was using much smaller, totally wrong numbers for the Earth's size. And it's a good thing he was. If he had known how big the Earth actually was, he would have known he didn't have enough supplies to get to India. He probably never would have set sail at all. His famous discovery was basically built on a lucky mistake, on forgotten knowledge. And all this really leaves you wondering, doesn't it? It makes you ask, why do the right ideas sometimes lose out to the ones that are just good enough? The history of ancient astronomy proves that the road to truth is anything but straight. A brilliant idea can get shot down, while a flawed one that fits what people want to believe can last for over 1,000 years. It's a huge reminder that science isn't just about the data. It's about us, our culture, our beliefs, and what we're actually ready to hear.